Now let's set up the Modbus device. Firstly, in our code, we have these Modbus registers that we need. Let's implement these and create Modbus registers based on them. Navigate to the Projects and Hardware Configuration. Locate the Modbus Devices section. On Fidelix system, Modbus devices are register tables, which communicates and transfers data between devices. Here you can upload, but first we will create those devices. Select port 5 and add a device. Set the address to 1. Let's name it HDH. You can choose any name. I use HDH because it's the sensor's name. Click Add. You can add more devices or return with Cancel. Here we have address 1. Add a type for all the devices. For example, we need a coil starting from 0 with a count of 4. Click Coil Start 0, set the register count to 4, and the timeout can be around 150. Click Add. Do the same thing for input register with the same settings, starting from 0 and a count of 4. Click Add. Similarly, add 10 holding registers with the same settings. Lastly, add a holding register. Set the start register to 9 with a register count of 2. These devices will be displayed here. Now you can upload the Modbus device to the PLC. If we go to the PLC settings, navigate to Ports and activate port 5 for Modbus. This is where we have connected it. Set the parameters to 8.1.9600 to match our bus and device parameters, and click Change to apply the settings. Next, go to the Programming and Modbus devices. Here, you can see that some messages have been sent, indicating that the device is now communicating. Down here, you can view some values. Let's go to the ST Edit page. Here we have QEFM and TEFM. Perform a syntax check and upload the code. It seems that the code was loaded successfully. Now you can see the values at the input register. Register 0 means that the start register from above. For example, here we have a value of 1129 for CO2 and 209 for the temperature, which are matching on manufacturer Modbus registers list on 30,001 and 30,002. Modbus doesn't allow you to send decimal numbers, so data is sent using the whole number and use a multiplier to change it to the actual value. Check the user mode and the graphics page created for this project. You'll notice that the value is the same here. It changes with 1 decimal point or 2. Note that the point names have to match with names used on the code. CO2 has also changed, confirming that it works and provides meaningful values. This is another way to verify if it's working. You can check the Modbus devices, the values, and the graphics, then analyze whether the values make sense or not. For instance, a temperature of 20.7 makes sense. If you have multiple devices, it's very important to ensure that you are reading the right device. If you need to adjust the multiplier, say it shows a value of 207, go to the STEdit and open the actual function block on the right. For the input register, you'll find the multiplier. If you delete the 10.0 multiplier for temperature and upload it, it will show a value of 206 in the graphics. That's why there was a multiplier of 10. Of course, we will change the right multiplier back. That concludes this video. Thanks for watching.